Okay, so maybe you heard of p-value, and it's kind of exciting that you remember even seeing that. But so here's going to be a refresher on what is the p-value, and then you're going to remember now, you're going to take the midterm exam, and then you're going to forget again. And if you stay in science, you're going to be reminded what it means. If you don't stay in science, it will play a pretty small role in your life, but it's good to know what is the power of the p-value. And unfortunately, I have to tell you that there is a thing now that's called p-hacking, which is people come up with a hypothesis, they collect data, they run the statistics, they calculate the p-value, and if the p-value didn't say what they wanted, they go back and collect more data and keep doing that until the p-value says what they wanted, which is it's frowned upon. But people do that because if your p-value is nothing shocking, then it's harder to publish that paper. And that's why some people are like, maybe we should stay away from p-value. But for now, it's really important. So is the probability, so the P is for probability that the difference observed. So when I say the difference observed, you're comparing two things, right? In this case, you're comparing the female shoe sizes with the male shoe sizes. There is some difference. Okay, I see the difference between that. So is due to randomness, meaning I see a difference between female shoe sizes and a difference between between female and male shoe sizes. And then the p-value would tell me, yeah, okay, there is a difference, but the difference you see is mostly because of randomness and not because you measure, because of the gender. So we'll go back to the hypothesis in the end. But in this case here, I'm not actually comparing the shoe sizes. Remember the F test? So here we make it maybe a different color to draw your attention that we are doing different things here. One test is looking at differences between something, and the other test against something else. The example I was using now to explain the p-value, when I'm looking at the difference in average of female shoe sizes and male shoe sizes, that would be the result here. That would be the p-value of my test. And then now here, this one is the p-value of my F test. So the F test is looking at the variation, the difference in variation here and here. So remember how I was like, oh, that looks like there's a lot more variation here because the range is really large, it doubled. And then here, there's not that much variation. So does it mean that there is a statistical difference in the amount of variation between these two groups? And then the p-value spits this, which this is saying there's a 97% chance that the difference I saw in the variances is randomness. So it's not those two groups that I compared do not have statistical difference. So the difference is not statistically significant. And you might wonder, how do you know that by this number? Well, because there's something that we adopt. Actually, let me do it down here. Something else you want to know is called the critical p-value. So the critical p-value, I compare it to like limbo bar. I wonder if the thing is going to complain that I put equal. Let's see. Okay. So the critical p-value, you know what? I'm going to put here. Is kind of like a limbo bar, which is some threshold that you adopt, and then whatever is under that threshold, then we're going to say statistically different, and then above it we're going to say is not. So let's see this. And there are different p-values you may accumulate, you may consider. The common ones that you see in paper are either 0.1. That's actually not a very common. That's kind of a high limbo bar, like you could cross under standing. Well, maybe not me. I'm like 5'11". Or 0.05. So there go that one is the most used one, which is like 5%, right? So normally, normally you adopt this, and maybe your data will have significant difference, maybe you will not. And sometimes, if you need to be more stringent, you adopt an even lower p-value, a critical p-value. So these numbers here are set by you, the person that is writing the paper, that's doing the science. This is not calculated. The one that's calculated is the one the statistical test spits out. So if you say, I chose my critical p-value of 0.1, that means you're being pretty lenient in when you are looking at differences. You're basically saying, there's just a little bit of difference, but I'm already going to say significant. You adopt a critical p-value that is lower whenever you can afford less to be wrong. So, okay, now let's see, what does that mean? I'm going to write it up here. And I don't know if this is large enough for you to see, but let's say if the calculated p-value is greater than or equal to the critical p-value. Okay, so think we have this calculated p-value, and then we have this critical p-value. We compare them. If the calculated is the same or greater than the critical p-value, there is no statistical difference between the groups compared. Okay, so let's see, this is the part where you are going to participate. This thing here, and we're going to adopt, let's adopt 0.05. That's pretty common for people to adopt 0.05 for a critical p-value. All right, so what I want to know is there statistical difference between the variances of female, male shoe sizes? All right, so let me know, is this a yes or is this a no?